Good morning to everyone, my dear students. Today we will learn Unit 3 Error Detection and Correction. Okay, error detection. Networks must be able to transfer data from one device to another with completely accuracy. When data is transmitted from one device to another device, the system does not guarantee whether the data received by the device is identical to the data transmitted by another device. And error is a situation when the message received at the receiver end is not identical to the message transmitted. Data can be corrupted during transmission. For example, system computer A, for example, system A send the message to another device, system B. The time data transmitted one device to another device. Some using some medium wireless or cable. The time some magnetic or noise effect, the data will be lost. The time the error detection and correction are implemented either at the data link layer or the transport layer of the OSI models. Okay, what is error? Error is the condition when the output information does not match with the input information during transmission. Okay, that means a 0 bit maybe change 1 or 1 bit change 0. Computer A send message to computer 2. Okay, in digital signals, that means zeros and ones. The time noise, some affected or magnetic effect, the data will be differences. For example, computer A send a message capacity 2 KB. Computer receive the data size 1 KB. That means this during this time, transmission time, the data are lost. Okay. Types of errors. Errors can be classified into two categories. Single bit error. Another one, burst error. Single bit error. Okay. Single bit error, only one bit in the data unit has changed from 1 to 0 or 0 to 1. Example, computer A is a sender, computer B is a receiver. Computer A send a data, some 8-bit data. Computer B received a data 8-bit, but this bit 0 bit is changed to 1. That means it, transmission time error is occurred. That is called a single bit error. Only one digit, 1 bit are changed, 0 to 1 or 1 to 0. Okay. Next one, burst error. The burst error means that two or more bits in the data unit have changed. In the above figure, the message which is sent computer A and computer B receive the message. Bits corrupted by the burst error means, listen here, single bit error means only one bit. Burst means more than two. 1, 2, 3. Length of the burst error 5 bit. That means first 1, 2, next counted 3, 4, and last one 5. That means 5 bits error. Okay. In case 6 bits means this value changed. That means 0 to change 1, 1, another one 0 change 1. That means 6 bit starting to ending. That is called burst error. Okay, 5, 3, 4, 5 bits are changed, 0 to 1 or 1 to 0. The burst error is determined from the first corrupted bit to the last corrupted bit. Okay, first corrupted bit to last corrupted bit. The duration of noise in burst error is more than the duration of noise. Burst errors are mostly likely to occur in serial data transmission. The number of affected bits depends on the duration of the noise and data rate. Okay, next one, error detection. The most popular error detection, it is a most popular concept, error detection. Error detection means to decide whether the received data is correct or not without having a copy of the original message. Okay. Redundancy, it is one of the technique. Error detection use the concept of redundancy, which means adding extra bits for detecting errors at the destination. Okay, redundancy. Okay, it is a original data. Generating function redundancy. That means this original data to generate redundancy concept. That means extra bits. Redundancy means the calculating new extra bits. Okay, it is a redundancy data. Sender computer A send the data with data and redundancy data. It is a original data and redundancy data. Receiver, same checking function. Check the concept. This data, the redundancy data is modified in case reject, otherwise accepted. Okay. Next one. Example. Suppose the sender wants to send the word in the ASCII. The 5 characters are coded. Okay. W O R L D. That means this is a original data. This is a original data. Send computer A to computer B. The data, the WORLD, this data is a message. transmitted into receiver. In detection concept, redundancy add one extra bit. This is original data. This is original data. Original data. WORLD. Okay. Now add a new some number. What is this number? 0. That means you have to calculate, count one, only numbers 1, 2, 3, 4, 5, 6. 6. 6 is a even number. That means you have to write 0. Okay. Next, you have count a number, only one. 1, 2, 3, 4, 5, 6. 6 is a even number. You have to write 0. Next, you have to count this number 1, bits 2, 3, only once 3, 4. 4 number. 4 is a even number, 0. Next bit count L 1, 2, 3, 4. 4 number. Number 4. That means number 4 is even number. You write 0. Next one 1, 2, 3. You count 3. 1, 2, 3. 3 is odd number. That means you have put 1. Totally these data are converted into even priority. That means even numbers, even numbers. Okay. Computer A send the message world to computer B. This data transmission, okay, into system computer B. Computer B received the message. In case you have to same check the data is right or wrong. 1, 2, 3, 4, 5, 6. That means even. Okay. Next O 1, 2, 3, 4, 5, 6. 6 is a even number. That means 0. 1, 2, 3, 4. Even number 0. 1, 2, 3, 4. Okay. 4 is a even number 0. Okay. Right. 1, 2, 3, 4. Okay. Even number. Okay. The receive counts. The one is the each character and comes up with even numbers 6 comma 6 4. That means 6 even number, this one 6, this one even number 4, this one 4, this one this 4, this one. That is WORLD. The data accepted. In case any data change are 0 to 1, that means error is occurred. Okay, now discuss error detecting techniques. 4 types of redundancy checks are used in data communication. VRC, LRC, CRC, checksum. Okay, first one. What is a VRC? Vertical redundancy check is called VRC. This is a error detection technique. A redundant bit called priority bit is appended to every data unit so that total number of ones in the unit, including priority bit, becomes even. This technique, a redundant bit, also known as a priority bit, if the number of bits is add, then priority bit 1 is appended, and if the number of ones bits is even, then priority bit 0 appended at the end of the data unit. Okay, data 1100001, that means this is original data. Even priority check generator, that means first this original data you have to count 1 2 3. 1, only you have to count number once, only numbers count 1 2 3. 3 is a odd number, that means you have to put 1. That means these total numbers 1 2 3 4, 4 is an even number, that means mm, even priority check. That means the sender, the values send, add 1, that means these data original data with VRC data, that means total data became a E1, 1 2 3 4, E1. Receiver receive the message check the data is total number of ones is even. The receiver check the same data 1 2 3 4 is even, that means receiver accepted, otherwise rejected. Okay, longitudinal redundancy check, LRC. LRC is an error detection method for determining the correctness of transmitted and stored data. LRC verifies the accuracy of stored and transmitted data using priority bits. It is a redundancy check applied to a parallel group of the bit systems. Okay, this original data, system A send a original data. Performance can be improved by the using two-dimensional periodic check, which is organize the data in the form of the table. Okay, priority check bits are computed for each row, which is equivalent to the single priority check. Two-dimensional party check, a block of bits divided into rows, and redundancy rows of bits added whole block. Okay, okay. First one, second data, third data, fourth one data. Okay. Redundancy means you have to add extra bit, extra value, extra bit. Okay, you have to add extra bit. You have to count this 1 2 3 4 data. 1 1 3 4. That means 4 number is even, 0. 1 is odd or even, odd, 1. This you have to count 1 1. That means 2 is a even number, 0. 1 2 3 3, 3 ones, that means 3 is a odd number, 1. 1 1 2, 2 is a even number, 0. 1 2 3, 3 is a odd number, 1. 1 plus 1 2, 2 is a even number, 0. 1 1 1, odd number, 1. It is a LRC value. This original data plus LRC, you have to send system A to system B. Okay, this is the original data 1 2 3 4 original data, and add LRC value, send. System A send the data, system B receive the data. This is original data, this is LRC value. Calculated the LRC for data received. In case these data is no changes, that means the value, the original data is accepted. In case LRC value is changed, then system B is rejected. Okay, LRC calculate with the receiver value. This value again you have to count 1 1 1 1 1 2 3 4 0 0 comparison 0. Next one 1 1 1. That means odd number you have to write 1. This one 0 0 1 1 1 1 even 0 1 1. That one fourth one only 1 is there. The odd number is come 1 1 1 1. The 3 odd number. Okay, 1 1 even number 0 1 1 1 3 odd number is 1. Okay, next one CRC. It is a very important topic in detection technique. Given a k bits frame or message, the transmitter generates an n bits sequence known as frame check sequence. It's called FCFS. So bits is exactly divisible by some predetermined number. The receiver then divides the incoming frame by the same number, and if there is no remainder, assume that there was no error. Okay. Now go to check cyclic redundancy check data CRC value divisor reminder CRC. Okay, in CRC data and CRC value to n bits and divisor n plus 1 bits, the binary division with come to value CRC, and the CRC value plus data received the receiver, uh, and again using binary division divisor, then finally remainder is 0 accepted, non-zero rejected. Example, the given data is 100 100. Okay, data plus extra 0, number of 0 is divisor minus 1. That means in divisor is 1101, 4 digit. You have to add this original data to 3 zeros. Okay, and you have to understand, I think divisor is 4 digit, 4 minus 1 3 0 using. Okay, divisor value 1101. You have to multiplication 1. 1 is 1101. You have to calculate 0 plus 1 1 0 0 0 1 1 0. This 0 come 0. Okay, second 1 into 1101. That means 1101. You have to add 110. That means 0 plus 1 1 0 0 0 0 plus 1 0. The re-again multiplication into 1 1 0 plus 1 1 1 1 0. re again into 1, 1 1 0 1. You have 1 plus 1 0, 1 plus 0 1, 0 plus 1 1, this 0 come to 0. Okay, if leftmost is 0, then must use 0 0. You have to add 0 0, and you have to add in this number, putting 0. You have to calculate 1 plus 0 1, 1 plus 0 1, 0 0 0. D again you have to multiply it in 1, 1 1 0 1, 1 1 0 0 1. Remainder is 0 0 1. This value, you have to re again calculate. Same, you have to put this value, CRC value 0 0 1. Same, you have to calculate 1 into 1 1 1 0 1, 0 plus 1 1, 0 plus 0, 1 plus 1 0 0. 1 multiplied this 1 1 0 1, 1 1 0 1, 0 plus 1 1, 0 0 0, 0 plus 1 1, next 0. Okay, multiplied 1, 1 1 0 1, 1 1 1 0, next into multiplied 1, 1 1 0 1, 1 plus 1 0, 1 plus 0 1, 0 plus 1 0, next 0. Okay, if left most is 0, then must you have used same technique 0 0 0. So putting 0, last one, 1 into 1 1 0 1. Okay, remainder is 0. That means the remainder is 0 means accepted. The data are accepted. Okay, last one, checksum. It is one of the error detection technique. Checksum generates subdivided the data into equal segments of n bits each, and all these segments are added together by using one's complement arithmetic. The sum is complemented and appended to the original data known as checksum field. The extended data is transmitted across the network. Okay, sender, computer A send a message, receiver computer B receive the message. Checksum techniques. The sender follows the given steps in checksum. The block of units is divided into k sections and each of n bits. Okay, all the k sections are added together using one's complement to get the sum. The sum is complemented and become the checksum field. The original data checksum field are sent across the network. That is a original data. That means to add section 1, section 2 into section k. Total number of sums then become to complemented n bits. It is a checksum data, and send the data checksum and n bits to the or to send the message system A to B. Receiver receive the message. Receiver, the block unit is divided into k sections, each of the n bits. Okay, all the k sections are added together by using one's complement algorithm to get the sum. The sum is complemented. If the result of the sum is 0, then the data is accepted. Otherwise, the data is discarded. Okay, thank you.